All right, go ahead.
Okay, so this is the May 17th ad hoc meeting to talk about extension mechanisms for the cluster API group. I wanted to call one more meeting before we get together in person next week because some of us will have some travel time over the weekend. Not everybody's necessarily going, but to have a chance to try and come to a little bit closer understanding of exactly what the proposals mean and maybe some of what the open questions are so that we're ready to go Monday next week when we get together. So I didn't have a prepared agenda in terms of like a list of specific questions. Andy had been asking a bunch of good questions and comments, and we've kind of gone back and forth, and I felt like having an in-person-ish conversation might go a little faster. And then, of course, if other folks have questions or want to, chime in or give opinions or that sort of thing, I don't think the goal is to pick anything or make any decisions, just to make sure we understand everything. That seem good for everybody?
Yeah. So I know one area where we've been having a lot of discussion is around what a machine set is for.
Hmm.
And I'm wondering if it would be useful, since we have at least a few of the people who I've been commenting about that with here, if it would be useful to talk about the philosophy around replica sets versus pods and how that is translated to machine sets and machines.
Sure, that sounds like a good place to start.
So I will preface this by saying that um, hopefully everybody is open to suggestions, and ideas are certainly not set in stone. But from a historical perspective, if you look at Kubernetes and pods, clearly a pod is the basic unit that executes on the system, and a pod has one or more containers in it. And if you are defining a pod, you have to define everything that you want that pod to do. So you give it the containers, the images for each container, the command to run, any arguments to run, environment variables, volumes that need to be mounted and where they go, and so on. And uh, back before, or at the beginning of Kubernetes, above pods, there was something called a replication controller. And that's probably a bad name because it's a noun in the system. It's not. There's like a replication controller, which is the controller, and then the shorter form replication controller represents the resource that you would be creating. And the intent of replication controller is to create a series of identical replicas of a pod. And everything that you can define for a pod in its spec, you would see set in the replication controller in a field called template. So the template in the replication controller is essentially a pod spec. And that way, everything you define in a pod, you can define in a replication controller. And that got deprecated and turned into replica sets, but I don't have any additional comments on the distinction. So for all intents and purposes, we can basically just keep saying replica set instead of replication controller. But it's the same thing where there's a template and the template is the pod spec. And one level above replica set is deployment. And the purpose of deployment is to manage replica sets. And the example that I think works for understanding why we have two things that control replicas of pods instead of just one is that you may want to have 10 copies of your web app running, and that's in your replica set. And then you may want to roll out a new version of your web app. And you do that using a deployment and functionalities such as a rolling update, so that the deployment can manage effectively two versions of the replica set. You have the original one with your older version of your web app, and it's got 10 pods running. And then you tell the deployment, I'm going to change my image. And what the deployment controller does is it creates a second replica set that initially either has 0 replicas or maybe 1 or 2 or 3, depending on what the max surge setting is. And so the deployment controller, when you're doing a rolling update, is responsible for coordinating, creating new versions of the pods in the new replica set, while it simultaneously scales down old versions in the old replica set, with the ultimate goal being that you end up with a single replica set, and it's the new one that has all of your new versions of the web app. And so that's why we have deployment versus replica set, because with a replica set, there's no way to manage, no way to easily manage doing any sort of coordinated rolling update. So if everybody's cool with those definitions, basically the same thing applies to the way that machine set, and machine deployment have been conceived to date in V1 Alpha 1. So in a machine, you specify everything you need to run a server of some sort, and there's obviously some common elements in the machine. And then what you see in V1 Alpha 1 is this provider spec field, which is an inline place where you can put arbitrary data that is provider specific. So for AWS, that's oh gosh, I can't even remember the type, but it's like an AWS machine provider spec. And that has things like the instance size or instance type, so M5 large, maybe the region that you want to run it in, an instance profile, and things like that. And so that's what goes into a machine. And if you look at machine set and think of it like a replica set, everything that goes into machine set is essentially a template for a machine, with the goal being to have 5 or 10 or 100 identically provisioned and configured machines. And then similarly to deployment, a machine deployment sits above the machine set and allows you to do the rolling updates where you can surge up a little bit and scale down a little bit. And so you'll have 2 machine sets for a period of time while the rolling update's in progress, and then you'll end up with a single newer machine set. And so I wanted to mention that because I think that there's been some confusion around why I've been suggesting that trying to modify the machine set to add certain fields, because the machine set is the place where you're going to specify your user data, and that gets applied to the machines. I think there's just been some confusion. And if we decide as a group that we want to retain the philosophy that a machine set is literally something that replicates machines, then we wouldn't be adding any new fields directly on the machine set that represent user data or some sort of bootstrapping bit or anything along those lines, because you can't have a machine, or you can't have a machine set until you have a machine. And so in my head, it makes the most sense to think solely about machines when it comes to what are we provisioning, how are we bootstrapping, how are we configuring, and anything that's in the machine set layer or the machine deployment layer is really just about replicas and rolling updates or some other sort of update mechanism. And so I'm hoping that that makes sense to everybody, and that we can focus on the machine layer and what it means to configure, bootstrap, etc., and that all of that will just automatically be or will fall into place for machine sets and machine deployments, because again, they're really just about replicas and updates.
Okay, that makes sense to me. I think I may have been one of the people who was saying things that maybe implied some confusion. And I had been thinking about the data on a machine set. When you talk about it being a template, I had been thinking of it in terms of values very much like what you would actually use, but not what you would actually use. So with little placeholders in them or things like that. And it sounds like that's not really the case, that it really does just copy that data directly onto the machine.
At least as it's implemented now, given that it's based on the concept of how replica set functions, yes, there are no placeholders unless the system supports those placeholders. But generally, like the placeholders that you might find in the pods, for example, would be environment variable placeholders. So maybe we can identify some things that make sense for machines, but generally it's just, if you want to run a machine, you need to fully define it. And if you want to run 10 copies of a machine, you fully define it in the template in the machine set.
So one thing I would add to that is if we do end up straying away from this model, I think we need to seriously consider renaming to avoid potential confusion, because one of the ways that we introduce these concepts to users is by drawing the analogies to the existing Kubernetes objects that they may already be aware of. So if we no longer actually mimic the behaviors of those upstream Kubernetes objects, then we should really try to make sure to draw a distinction within naming to avoid confusion.
Yeah, I agree with that very much. Yeah.
Is there a reason to move away from those types?
I don't particularly see one. I think Jason was saying if we do, then we need to do it that way.
Okay. Yeah, that's fair enough. I think that there's a huge value in the similarity and analogy between existing types and new ones, and it greatly simplifies onboarding people to the API.
Yeah, yeah. Okay, so I think given that understanding of basically, I guess the same object that's attached as a provider spec. I mean, with a provider spec, we're copying data from one object to another, so it's a copy. But in this new model, the data model that's kind of been proposed is to have a reference to another object that has the provider specific data in it. And if we follow that model, then we might just copy the reference, which means we have the same object being used by multiple machines. Do we feel comfortable with that? Or do we feel like we need to make a copy of that object to ensure that they're unique and clean?
So I think one of the things that we can do as we define the API is we can declare that certain objects should be immutable. And in this case, I don't think we necessarily want to copy that data. I think the one thing we want to avoid is the provider-specific blobs that are embedded right now, because the management and validation of those is more complex than it really should be. So the references help simplify that, and that we can just have simple admission webhooks to handle validation that are provided by the actual implementers of whatever the extensions, whatever we're calling the extensions in V1 Alpha 2. So the simplicity of that model makes a lot of sense. But I think one of the things we may want to require of it is that these references are immutable, that they're not updated after they are created. And then that would solve kind of the issue of linking these references in multiple places.
Yeah. Is that a pattern that's followed elsewhere? Like I've said before, I'm kind of new to all of this stuff. So does Kubernetes do that in another place where we wouldn't be setting precedent ourselves, but we'd be following one?
I'm not sure.
Yeah, I see a lot of people with looks on their faces like they're trying to look for an example. So
I know in places that Kubernetes enforces idempotency of certain fields on objects. I don't necessarily know if there's any enforcement of full objects as being immutable. That said, it seems as if it would be relatively trivial to handle as part of an admission webhook.
Sure. I mean, it's easy enough to implement. I wasn't worried about that. I was, if it's going to be the oddball thing that no one else does, I was looking for, do we want to consider whether that's a thing we want to take on? Yeah. Alan had a question in chat. He said he can't really be on the phone. It looks like, are people answering in chat there about what is the equivalent analogy for machine class, similar to what Andy went through with the other objects?
I'm actually on the phone. I just didn't think it's probably not important enough to discuss here, and we already kind of moved on. But it was relevant to what Andy was going through. I just thought for completeness, if we're gonna elaborate on machine set and machine deployment, we might as well cover the sort of etymology of machine class and figure
I
out
do think
what
it's worth discussing. So
because the other ones I think are easy to sort of draw that directly, just how you did, but that one is a little harder.
Yeah, the way that machine class works in V1 Alpha 1 is it gives you, it gives you the opportunity to take the provider specific data. Again, this could be instance type, region, networking details, storage details, whatever provider specific, put it in a single place and use it as an object reference when you're creating or when you're specifying a machine, be it in the machine set or machine deployment. So if you were creating 100 machines by hand, then you either can copy and paste all the details that are provider specific into each machine, or you can have them reference a single machine class that has all of that information. So it's a way to consolidate and save on copy and paste errors. But I know Jason has talked, I think maybe in the data model proposal, if not somewhere, about trying to change machine class going forward so that it's more about sizing and capacity planning and have it be more in line with storage class and not use it as a placeholder for all provider specific information as it relates to a machine.
So I can speak a little bit to some of the rationale behind that. Machine class originally was introduced as a way for providing support for interacting with autoscalers, so that there's a way that you could generalize the scheduling information for machines and be able to use that to feed into the autoscaler to be able to make scheduling decisions. And the way things work today with the providers, the provider specification provides not only that sizing information, disk space, CPUs, additional resources such as GPUs, memory, those sorts of things. It also provides a lot of other things, and it provides a lot of things depending on the provider. So, for example, the GCP provider, it doesn't have any impact on the configuration for bootstrapping the node as far as like kubeadm configuration, because that's fed into the GCP provider through another mechanism. But for the AWS provider and other providers that allow configuring the kubeadm init process through the provider spec, now that's also baked into the machine class as well. So instead of representing like small, medium, and large, for lack of a better term, now it's representing a whole lot of other conflated configuration as well in today's model.
Okay.
Have we considered a concept like resource request, kind of like how pods have resource requests? Because that seems to make it more explicit, like this machine is requesting a 10 gig network link and 4 gigs of RAM and 80 gigs of disk space, and then we try to get that.
So one issue that I potentially see with that is that I think we're ending up in a place where we're requiring providers to implement a lot of logistics around how do they fit that into the different models provided by the different cloud providers. So like in the GCP world, that's not actually that bad, because you could specify however many CPUs and how much memory you want for instances in a relatively arbitrary manner. But trying to map that specifically into like AWS sizes, or even if you're talking about the OpenStack world where you have administrator defined classes, now you're in a place where doing that mapping is going to get pretty intractable pretty quick.
Yeah, I think the simplest implementation would be to treat them as minimums, but you don't always have something that matches all the minimums. So yeah, let's keep it simple and let's call it machine class, but let's not couple that with initialization would be what I would say.
Yeah.
Yeah, I like that idea a little bit. I mean, coming from the bare metal case, like I probably have even less flexibility than an administrator configured cloud, right? Like I've got exactly certain machines that I can actually deploy to. And, you know, so best fit is probably going to be way bigger than some minimum that's been specified.
Alan, would you mind muting?
Thought I was, sorry.
No worries.
Although he is typing up a good comment and question.
Yeah, thank you everyone for helping take.
Yes.
Yeah, I was just trying to record some of the notes. I don't mean to hijack the conversation and keep this going. Some of this I'm fine to just put in here in the notes and take it. So maybe if people want to discuss other things, we can move on. Leave it up to you guys.
So there was a question posted here about do we agree that both cooperating controller and webhook proposals can meet CAPI use cases?
Yes.
Even if we disagree on which is better. Oh, that's you. Yeah. So
Yeah, because I thought that's what this meeting was about.
Yeah. Well, yeah, I like I said at the beginning, I didn't necessarily want us to try and decide anything, but I do want to make sure that everything is clear so that all that plain time everybody's going to have between now and Monday, you can spend thinking about what the proposals mean. Yeah.
Yeah, I have to be honest, I haven't read them. Are we doing both controller and webhook?
Well, we're still trying to decide which approach to take. And so we have both proposals up so that they can be compared and commented on and contrasted. Yeah.
Okay.
So I may offer up kind of, it may be a controversial opinion. I don't necessarily know if it needs to be an either or situation. I think by enumerating the different proposals, I think we should at least be open to the potential that there may be a best fit based on what type of extension point we're talking about and the use cases for the specific extension point. I don't want us to necessarily think in a black and white type, situation here.
Sure. Yeah, that's a fair point.
Pablo's got his hand up.
Oh yeah, sorry.
No, yes, I raised a hand before. Jason basically saying the same that Jason just said, is that probably the most important part for that to happen is that the data model supports both. And I think that in the shape it is probably so. So we can delay the decision, as you said. Probably we can start like doing something at some point. We decide that probably some part of the workflow is more adequate for one or the other, for instance. But we need to try to keep this open. I mean, probably we'll not know that beforehand until we try to do it, because the workflow is really complex.
I think Daniel had his hand raised.
Yeah, that's actually, I think the heart of the question. And please, like Jason, I think you jump in, correct me if I'm wrong, but with webhooks, the communication mechanism, right, is not by posting to the API server, so that I'm not sure how we could have a data model where we have like the synchronous webhook communication, but also something that will work for controllers, which I presume will be using, by reading and writing to and from the API server.
Yes, and I wanted to contribute to this discussion by letting everyone know why I prefer controllers. And the reason is that with the controller model, your functions that operate on the current state happen to have visibility to the state of the entire system. So in a webhook model, we have to define an API for each hook. Like if you look at the CSI, that's their primary motivation, is defining what parameters exist for each event that you might want to hook into for a disk. But in our case, because we have such varied use cases, this is what I was trying to get at like last Friday or whenever that was. I might at initialization time need to know the data, the metadata for post initialization time. So in the controller model, I have complete freedom to do that. And so it's not because I've already written a controller in Go, which I have. It's really because I think the controller model is the best way to do this. And if you look at the pod controllers in core Kubernetes, you'll see we can use like many of the same concepts there, like even with the scheduler and all that.
So, I'm sorry, did anybody have their hand raised?
There's at least a couple.
Okay.
So, Pablo, I think your hand was up from before, and I don't think you put it down.
Yeah. Just because of the question of how we can actually make this data model work for both approaches. I think that as long as we keep the provider-specific port as reference to external object and not embedded, that opens the door. I think that was the main obstacle we had initially, that any external CRD controller cannot easily be implemented because the provider-specific data was inside another object. But once we have been moving to this model, I think is a first approach. And the second one was a proposal, I think it was from Vincent, that even when the workflow was like a model, like calling external webhooks, those were optional. It's like if you register something there, you call it. If not, you assume that somebody's taking care of that object. And I think that is more or less the way I see it could probably be the future. It's like being flexible. Say, we define a workflow with some specific calls, but if there is nothing there, well, we assume there is an external controller. We need to go over all the workflows to be that it works or not. But I think this is very much the way I see it happening. That's why I've been saying that for me it's not either or. It's like they can coexist, even in a provider by provider basis.
Okay, Daniel, you have your hand up.
I do still.
Okay, now it's down.
No.
All right. Well, I had mine up, so I'll go if that's cool. So I want to start off by saying, like, I'm not against controllers, but I have some questions that I honestly don't know the answers to. So please don't think that I'm necessarily attacking things, but I'm just trying to get some clarity here. So I'm looking at the machine spec as it currently stands, and it has taints, which is optional, and you can hope that your infrastructure provider will set those taints on the node that it creates. There's the provider spec, which we're all familiar with, the versions field that says I want this version of the control plane and this version of the kubelet. There's a kubelet configuration field, which I don't know if anybody's using that, and then an optional provider ID, which gets filled in the spec, assuming your provider does it after the server has been provisioned. And what my question is, so if we have an AWS machine config and a GCP machine config and a bare metal machine config, and these are all provider specific, and presumably they have all the stuff we've been talking about before in terms of sizing and whatnot. How much of the stuff stays in machine spec, and how useful is the machine object at the end of the day if it generally has a reference to something that's provider specific? And I'm asking this because if this were, let's say, Ruby on Rails, where you have polymorphic types, and you can have multiple tables and have a base table, and you have an AWS machine config table and a GCP table and whatnot, then in Ruby on Rails, you can say, go give me all the machines, and you'll get back an array that has AWS machines and GCP machines, but there's no real generic like machine type. And we're sort of at the mercy of the API machinery that Kubernetes has, where there is no polymorphic machine that we can work with. We can define a machine as basically as a placeholder to give it a name so it can point to the polymorphic aspect, which is the AWS config or GCP or whatever. And so I'm trying to figure out, like, if we keep things kind of the way that they are, like, what is the overall purpose with machine, unless it's just we need it because we want to be able to queue control get machines, and here they are.
I think Michael was next.
Well, that's actually a really interesting question. I was going to ask a different one, but I can actually contribute a little bit to just answering that. It seems like one of the primary value points of having a machine object is to have something to grab onto for lifecycle events, like something to uniquely identify that machine, the health of it, and I've seen the network addresses, for example, being used to correlate a machine with a node after the node pops up, those kind of things. So in some ways, the status of the machine almost seems more valuable than the spec, which, as you pointed out, has a lot of stuff that might be better served going into provider-specific data structures.
Daniel was next, I believe.
Yeah, I'll just second what Michael. I think I'm seconding what Michael is saying. It's to me, the machine object is a point of synchronization, where multiple controllers, read and write and figure out what maybe phase the machine is currently in, and the machine controller, the capping machine controller, is what's in charge of shepherding that object from phase to phase. It's in charge of orchestrating the controllers, or maybe indicating to the controllers, okay, now it's your turn to do whatever you need to do on this object. Now it's your turn, etc.
Doug?
Yeah. So that, since I wrote the original version of that proposal, I've had some conversations with folks that suggested that maybe we don't need that particular piece where we're orchestrating the phases. And I haven't thought through the implications of all of that on my own, but I wonder if that's a thing that is also worth thinking about, is, they sort of coordinate without being explicitly controlled in lockstep in some way. So, and that's, I have an example of that in what we've done within MetalCube. We have a couple of different controllers that work together, and they just sort of sit there and wait for the object to have enough data to do the thing that they need to do next. And so until it's filled in, and so maybe that's kind of also an answer to Andy's question, which is we put a few fields on the machine that get filled in by providers that are doing individual pieces of the setup. And as those reach a state where the next thing has enough information to do its job, then it does its work. So
I think the phases are valuable. I think status is also valuable in the sense that if we have a machine deployment and that deployment needs to bring up a new machine if the machine has gone down. So like, not even in the rolling case, right? It's just the case where the machine is now shut down or dead. Now that machine status is powered off or whatever, and then we can bring up a new machine. Jason?
Yeah, so sorry, I apparently can't raise my hand in the chat because I'm a host. One of the things I wanted to say is I think most of the discussion around management of the state and everything makes a lot of sense, in how we've been discussing around like infrastructure providers. One of the things that I worry about, if we start talking about bootstrap providers, especially ones that may be built around like kubeadm, where we may have to vendor in specific versions of kubeadm to provide specific support for specific Kubernetes versions. I do worry in like the pure controller model that if we have two different controllers running, we're basically trusting those controllers not to both act on the same request for Bootstrap information for a specific Kubernetes version. That's kind of where I see like maybe the webhook model having some specific benefit, because you would be able to register for like a specific version of Kubernetes and know that there would be only a specific instance that would be acting on that, instead of potentially just trusting the deployment in that case. And I'm not quite sure who had their hand up next.
I think last, so I don't know who was next.
Oh, okay, there's a lot of people. It's just briefly, just to the comment that we don't really need the coordination explicitly. Yes, we don't have to, but I think it's for sanity of people, it's better to have it. I mean, even we can do it implicit, event-driven workflow, just based on the cooperating. The problem is that somebody jumps into that logic, it's really hard to get it. So I think that having an explicit workflow, even if that workflow is only creating the CRDs and the controllers are just working on that object, make explicit the workflow and easier, because it's going to be complex. That's the point. So yeah, we don't have, but I think it would probably be a good, we'll say, practice to make it as explicit as possible.
And I think Alan was next.
Yeah, I have a quick one. I don't know if this would be helpful or not, but this goes back to the point that I think Doug made a little bit before in terms of the state of cooperating controllers right now, sort of watching for things to be populated, and then when they see the right things, they sort of move forward. I guess my quick point here to maybe the wider brain trust is, I feel like this is a wider problem than just controllers. We have the same issue when we talk about operators as well. We want different operators to play with CRDs and also make them a little bit more pluggable. And I guess I'm sort of wondering, I wonder if other people besides this community are thinking about this problem, because there's sort of there's an analogy here between what we're trying to do here and, even something that has nothing to do with the cluster API, just operators trying to work together against CRDs, and also to, have the opportunity to make them swappable. And I don't know whether any effort is also going on there that may help this topic.
All right. I think Michael was next.
Yeah, I was going to say, when it comes to relationship of the life cycle of the cluster API components, including these extension points, what we're currently talking about, Bootstrap controller. At some point, presumably, you might need to carry two Bootstrap controllers, one for current version and one for previous version, in case you need to roll back or what have you. And so there probably needs to be a mechanism that supports a use case where the right controller picks up that. I think maybe that's best done maybe via labels or annotations. Like having a specific field and having two things watch that field, you're going to be in a competition. Whereas if I label this machine ahead of time, this is version whatever. And so when this thing sees like, okay, this thing's booted, machine's created or whatever, okay, does this match my version that I care about or whatever string I care about? Yes or no. And then, that way you don't have a race condition between multiple Bootstrap controllers or what have you.
Andrew?
Yeah. So first I'll respond to Michael's point. So these controllers would be Kubernetes deployments or stateful sets or daemon sets, however we actually deploy them. So just like with a Kubernetes API versioning, the controller would be observing objects with a certain API version. And if there was a field for Kubernetes version, then the functions of the controller that would perform a reconcile on those objects that it's watching could have a lookup table for different versions and could do different things depending on the version. So I don't think that's a huge issue of like contentious controllers. What I do want to caution us against is tying us to specific tools, even like kubeadm. So I know this is a controversial thing to say, but we can have a field that abstracts over the metadata that kubeadm wants, and then avoid some of these issues with transient versions and stuff like that.
Andy?
So, yeah, I agree with what you just said, Andrew. As far as the kubeadm abstraction, hopefully we can come up with some part of the data model so that you can say, I want a control plane or I want bootstrapping, and then you can swap out your specific provider for bootstrapping. And if you pick a kubeadm bootstrap provider, you would have a reference to a kubeadm specific, provider specific CRD instance that has all the details. And if you don't want to use kubeadm, you could use some other specific one. Or I think maybe what you were getting at is kind of genericize that and make it translate to the kubeadm based implementation or not. But anyways, like I think they're solvable problems. So the reason I had my hand raised is this is a bit of a transition, and we can defer this if y'all want. But I did want to mention the post that I wrote on Discuss, where I highlighted. Apologies, I don't know who wrote it, but the flow of how do we get the cooperation between something like I need to create a load balancer for my API server and control plane, and that DNS name needs to be fed into my my kubeadm or other API server configuration. And so there's a orchestration that needs to take place, and I feel like it's a workflow that needs to be defined, and there needs to be one or more sequences of steps that some of them are hard-coded and not swappable, and that's just what Cluster API does, and others are swappable to say things like, I need a load balancer, and it might be AWS or GCP or whatever. And I kind of feel like if we can talk through some of those, and I realize we only have about 15 minutes left in this hour, so it's probably not enough time, but if we can reason through some of those workflows, maybe it'll help figure out how we do this cooperation, be it with controllers or asynchronous webhook calls.
I do, for what it's worth, really like that approach of nailing down what that API is going to be, what that API experience is going to be, which might help us to better inform how we're going to actually do it.
Michael?
Yeah,
Michael?
Just a quick counterpoint to Andrew a minute ago. It is possible during one Kubernetes release that you might want to blue-green some changes to your Bootstrap configuration, config files, what have you. And so I do think it's important that you have the ability to support multiple different controllers or endpoints or whatever it ends up being for that part of the workflow.
Daniel?
Yeah, I want to respond to what Andy was saying. So in the past, I've tried to, reason about this sort of workflow by splitting, try to help myself reason about it by splitting it up into, completely independent phases, and sort of define sort of, okay, what do I need by the time that I want to bootstrap machines? I need to know the control plane endpoint. So if I need to know that, then, if I had an infrastructure phase that came first, either that would have, brought up an ELB or whatever else, right? The VIP. The main thing is that I have this control plane endpoint. And then, by the time you're done bootstrapping, okay, you need to, retrieve a kube config. What do you need to be able to do that? So, do others think that it's that's maybe one way that we could kind of break this problem down, and that we could, we have all these different providers. Could we diagram or write out, but in separate phases, and do things that way, instead of all of us sort of going end to end with some workflow. Am I making sense?
Yeah, so last Friday, I posted a state diagram of the node initialization process with states of like pre-booting, booting, post-booting, running, and we could even have like failed, needs upgrade. Like if you look at the state diagram for TCP, right? Like what is it called? Like time wait and established and whatever, like all the states for TCP, like we can have the same thing for nodes. And I think that most of them apply to everyone, and the ones that don't, you don't need to worry about. And you can just like flip the state from booting to booted if you don't need to do anything there. And if you look at the document that TSC is working on right now, I'll post it after the meeting. We're trying to define those, at least for the nodes, the machines. So, yeah.
I guess. Oh, sorry.
I don't know who was first, but Doug and Michael have their hands up.
Yeah, I think I was first, and responding a little bit to what both Daniel and Andrew just said. I think it's useful. It's very useful to think through what data we need in order to take each action. I'm a little bit worried about codifying that too much in a specific state diagram that we try to use to orchestrate things like in lockstep. Because I think some of the things can happen in different orders, some of them can happen concurrently, and I think that it's possible to allow that to happen, and for the object to sort of reconcile itself or become reconciled to a useful machine, without harshly saying you can only do this at this point, and then we're going to move to this phase. And I don't have a great example, but I feel like our workflows are slightly different. So I don't want to lock things down too hard.
Michael?
Yeah, I've shared a document in chat that Doug and Andy have looked at already. And I don't mean to be very prescriptive with exactly what the steps look like, but I do think we need a state machine. So I documented what I think like a high-level state machine would look like. And like just for the control plane pieces, I absolutely think we need some kind of state machine that knows what the load balancers are and all this kind of stuff to, intelligently feed that into each object. Otherwise, we're going to have references all over the place, and I think it's going to be very hard to get something consistent.
Vince?
I want to add a new point to the agenda, which should we set some dates around like when do we want to put the proposals in, and like because these discussions were very useful, and I got even more context about what others are trying to do. I do think we need to be concrete at some point. So what should we how should we move forward? Question to the group. And what is the target date? I know that we set a target date for the proposals. Should we rally against one proposal or multiple proposals?
Doug?
Yeah, I think eventually we should set dates. I'm a little bit worried about setting dates before I feel like we're kind of coming together on some sort of agreement, because if we force a date, then we might end up with something that no one actually likes, but it's what we all said, well, that's good enough for now. And then we're just going to end up having to go through all of this again. So I would actually rather delay things, not indefinitely, but have enough room for a conversation. So maybe coming out of next week, we can start thinking about dates. But I think it's kind of early to do that now.
I think I had my hand up next.
I think you were next, yeah.
So I was just thinking, like, I know that there was a control plane work stream that I was sort of thinking would be talking about some of these orchestration items that we've been discussing. I looked at one proposal a while ago, but have not had time to look at all of them. So I don't know if we want to try and coordinate with that group, assuming that there are different individuals involved, to try and document some of these workflows, or if we, I don't want to have fragmentation and duplication of effort. So I don't know. What do you all think?
I think Andrew was next.
Yeah, I don't have an immediate answer to the project management issue there. But I did want to reiterate that this is V1 Alpha 2, and I feel like we can actually set dates and iterate on what we have. And it's also interesting to me that we were going down the path of solving a bunch of these problems with machine status already. And there was something else that a hurdle for me was remote node references. So I haven't caught up with the cluster work stream. Have we solved remote node references?
Sorry, Vince, you were next.
I was gonna say something like about the dates that Doug brought up.
I can answer Andrew's question a little bit if you want to.
Yeah, go ahead. And
no, I don't think we have. I know that there have been some discussions around maybe we figure out some way to SSH in or some sort of remote access. My team has been working on this upgrade tool that I've mentioned previously, and the way that we're hackily doing it right now is we match the provider ID that's set on the machine spec to the provider ID that's set on the node. So that means that we need to be able to access the management cluster where the machine is and the target cluster where the node is simultaneously. It's hacky, but it does sort of work for now.
on the data model for that, we actually talked about remote node references in case of the management cluster, but it's like TBD on anything. In terms of date, I do 100% agree that this is V1 Alpha 2. And to give some context, we have been talking about V1 Alpha 2 way before V1 Alpha 1 actually was released. So kind of, I wouldn't say it's too early. I actually would think we're kind of like late in the process at this point. And that's why I'm trying to like kind of set dates, like not because we have to be super strict about it, but mostly like to kind of go into more concrete direction in next few meetings, like for like each the work stream that are like now closed, or like mostly like to see concrete proposals and anything else that folks want to add.
Yeah, so is there like an overall schedule that we're trying to synchronize with? Is there some sort of like we want to do something by a particular Kubernetes release or?
Not yet.
Okay.
I will say that some of the other work streams had set Friday, June 7th as a target for trying to have proposals vetted and submitted. So I don't know if that gives us enough time. Next week is KubeCon, obviously, so people will be busy and probably not working too much on these, which gives 2 weeks, 2 full work weeks after KubeCon to Friday, June 7th. Maybe good, maybe not.
For setting dates, just to ensure that we keep things moving then, or?
We need to be able to draw a line in the sand and say, like, this is what we're moving forward with, assuming the majority agrees. I think having a date helps, but at the same time, if the date comes and goes and we're still not in agreement, then I think we need to reevaluate.
I do want to stress out the fact that this is like kind of dates for proposals and not just like any kind of work. We can get an agreement on the proposal themselves when they get, like, we get a PR open, and if we still like kind of like in between proposals, like we can ask for help, like from the SIG leads and or like API reviewers. So the goal should be like kind of like trying to move forward with something. That might not be the best solution, but we should probably learn from what we kind of decide. And if that's not the best solution, then we can always like have a B1 Alpha 3 discussion. That's the purpose of this exercise. We don't have to have the best of the best at this point in time.
Yeah. No, I get that part. Okay. So I was going to raise my hand, and no one else has their hand up, so I'll just go. So I don't have a problem with setting some deadlines for getting some proposals written. I feel like maybe I misunderstood. I thought it was sort of agreeing on something rather than just getting stuff written up. And I feel like we're way too unsure of exactly what we want to do to agree on anything yet. And I hope that's resolved soon, but I don't necessarily expect that to be resolved by June 7th. Which brings me to the question of, how does this group actually make decisions like this? So how do we, if we have several proposals that might be either not necessarily competing but overlapping, say, how do we decide which ones to proceed with?
So I'm just going to jump in to answer that specific question on how, as a group, we decide. The first option, which is probably the best option, is to just have general consensus among the participants. If we don't have general consensus, then at that point, probably the second best option would be to have a vote on the topic. And I think one of the ways that we would want to address a vote is to put some limitations around that vote based on probably employment, to avoid any particular employer or any particular company, my own included, from being able to sway the decision too much. And then if we don't have resolution at that point, I think our next step would be to escalate to the SIG leadership. And I'm not sure if it was Andy or Vince who had their hand up next.
Andy was first.
Yeah, I think I did. So it might be a good idea, given that like David is saying concrete proposals and Andrew wrote he wants to see field names and data flows, which I think would be great. Maybe we could identify a few small scenarios. One could be, I want to provision a control plane and it needs a load balancer that can get ingress into my control plane, and that needs to go into a kubeadm config. I know that's very specific, but if we can try and put together generic fields for all of that and have it work for AWS, TCP, maybe bare metal, like that could be a somewhat self-contained or small flow. And then we could come up with some other ones, like I want to add a node to the cluster and whatever else. And then we could see what it would look like with controllers, see what it would look like with webhooks. Food for thought.
Again, no, go ahead.
Can I respond to Andy real quick, Vince? I know you had your hand up. Okay. I don't know if you're interested, Andy. If you're going to be at KubeCon, maybe we could, like collaborate on that, or asynchronously too. But yeah, what you were saying is pretty much what I have in mind. Like figure out this not the data model, not the schema, but just kind of a bag of attributes, right, that each phase needs. And once we have that bag, you know, the schema can come later, but at least we know, okay, here's what, you know, we need at least this information to make progress in this, you know, in this next phase.
Yeah, I will be at KubeCon, but also happy to do it asynchronously for anybody else who wants to participate.
So I'll go next. If I could make a request, so you know, doing this sort of scenario-based approach, you know, not obviously you don't want to cover every kind of scenario. Doing this is to help educate you on what the data inputs are. But if I could make a request, in addition to all the sort of simplistic things that you're talking about here, I think it would really help to throw in some sort of at least one weird complex scenario, like self-hosting the load balancer or something like that to help guide you. Otherwise, you're going to come up with something that's going to fit the simple use cases, and you're going to leave out some of the hard things.
Good point. Thanks.
We're at time. The only other thing that I wanted to add is there is a world where we kind of collapse the two proposals and we kind of try to meet each other halfway through, so that we don't have to escalate anything. Possibly, like when I say this in the open, like that would be my preferred solution, where we could find like some agreement before kind of trying to vote or like put work in that's gonna go to waste. Other than that, go back to you, Jason.
All right. Thank you, everybody. Did you have anything else before we wrapped up, Doug, since this was your meeting?
No, that's great. Thank you, everyone, for participating. I think that was really good conversation and helped move this forward a little bit.
All right. Thanks, everybody. I will probably wait until tomorrow to upload this meeting. But otherwise, thank you very much, and I'll get it uploaded and share the link out once I get a chance.
Thanks.
All right.
Bye-bye.
Bye.
Thanks.